Hi, and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to continue what we studied before about the reaction rate. Today we're going to focus on the factors affecting the reaction rates. Our new objective is to list and explain the factors affecting the reaction rate. So we need to list them, and also we need to explain each of them. Our vocabulary are the catalyst and the inhibitor. So, the first factor that affects the reaction rate is the nature of the reactants, because some substances react faster than other substances. For example, the iron rust, sometimes it takes weeks, sometimes it takes months, a few months to occur. So, for example, if we have Fe, it's reacting with O2, the oxygen, to form the iron rust, which is Fe 2O3. And to balance this equation, here we have 2 and here we have 3 over 2. This reaction, it takes time to occur. For example, if we have the methane CH4, and when we have the combustion reaction of methane, it means reacting with O2. It will give you carbon dioxide plus water. And here we have 2, here we have, that's it. So for this reaction, it takes maybe seconds to occur. So that's why the nature of the reactants, when they are different, we have different reaction rates. So the nature of reactants, because some substances, they react faster than others. The second factor that affect the rate of the reaction is the concentration. Because when the concentrations are increased, more molecules are available to collide. And we studied in the previous video that for any chemical reaction to occur, we need the collision between the particles. We need this collision to be in the correct orientation, and it has sufficient energy. So when we have more particles, or the concentration is more, that means more molecules are available to collide per unit of volume, and therefore the collisions occur more frequently. For example, here we have reaction A, and we have only 5 particles of the blue reactant and 5 particles of the white reactant. Of course, it's going to collide. Those particles, they will collide, but they will collide less frequently than reaction B, when we increase the concentration of the blue and the white reactants, because now they are colliding more frequently. So the concentration, increasing the concentration, it increases the reaction rate. The third factor is the surface area. The greater the surface area allows particles to collide also with many more particles per unit of time. So for example, here in A, we have low surface area. Even though the particle is large, but the surface area is lower, because now these two particles are colliding only in this area. For example, it's like this, in this area, which is small. And when we have this reactant in smaller pieces, now the surface area is greater, because the collision could be in all these areas. That's why when the reactants are powder, the reaction will be faster than when the particles are bigger solids. That means increasing the surface area, it will increase also the rate of the reaction. So now we have 3 factors: the type or the nature of the reactants, the concentration, the surface area, and number 4 is going to be the temperature. In general, increasing the temperature increases the reaction rate. And there is a reason behind this, because increasing the temperature, it increases the kinetic energy of the particles. When you increase the kinetic energy of the particle, for example, if you are talking about this reaction here, so that those particles, they will move more frequently, and the chance to collide is going to be more. That's why increasing the temperature in general, it will increase the reaction rate. Number 5, using catalyst or inhibitor. A catalyst is a substance that increases the rate of the chemical reaction, but without being consumed in the reaction. And how does it work? It works by reducing the activation energy. And we studied the activation energy in the previous video. As you can see here, if we have H2, this one here, and it's reacting with N2 to give you NH3, this reaction will take long time. But when you add a catalyst, now this catalyst will help the hydrogen bonds or the bonds between the hydrogen atoms to break, and also the bonds between the nitrogen atoms also to break, and the bond between the N with the three hydrogens, it will become easier to form, as you can see here. So this, we have now two molecules of NH3. And see, here we need 150 bar, and here we need less temperature with the catalyst. The inhibitor is the opposite. An inhibitor is a substance that slows or prevents the chemical reaction by increasing the activation energy. Now, to understand the catalyst, how it reduces the activation energy, and the inhibitor, how it increases the activation energy, let's take a look at this diagram. Here is the energy, the x-axis, and you can see now the red reaction is without catalyst. And the activation energy is from this point, because here is the energy of the reactants, all the way to this point. Here is the activation energy without a catalyst. But when you add a catalyst, the activation energy now it's lowered. That means this reaction can occur at lower energy. So the required energy, or the minimum energy that is required for this chemical reaction to occur, now it's lower. And that means we need less energy for these particles to collide, a correct collision with sufficient energy to make the chemical reaction. All right, now let's have a self-check. When concentration of a reactant is increased, the reaction speeds up, the reaction slows down, the reaction stops, the reaction rate does not change. Of course, increasing the concentration, that means the reaction speeds up. Number 2, when you increase the temperature of a chemical reaction, the reaction speeds up or slow down. Of course, it's going to speed up in general. And number 3, what happens to activation energy of a reactant, of the reaction I mean, when a catalyst is added or is present? The activation energy does not change, the activation energy decreases, the activation energy increases, or the reaction stops. Of course, the activation energy will decrease, and that's why the rate of the chemical reaction will increase, the rate. And the last question for today is, what might an inhibitor do in a chemical reaction? Does it speed up the reaction, drive the reaction to completion, raise the activation energy, or lower the activation energy? Of course, the inhibitor, it slows down the chemical reaction by raising the activation energy. I hope you guys learned something new today. If you have any question about the factors affecting the chemical reaction or the rate of chemical reaction, please write it in the comment and I will answer all the questions. Have a nice day. Bye bye.